I hope you can see my screen now, right?
Yes, I can.
Okay, perfect. All right. So let's work something out. Should not be an issue from my end. Give me a couple of days and I'll figure out my
No
schedule.
problem. Yeah. Yeah. Yeah.
All right. So today's agenda is going to be straightforward. I'll try to finish it off in an hour because it's mostly theoretical, right? Most of the questions that are asked here are fairly theoretical in nature, and we're going to cover two major things here today, right? And the first one is chapter 16, which is stochastic reserving, and the second one is chapter 19, which is ALM. We will also cover chapter 17 and 18 to a certain extent as well, although questions around these are more practical and common sense, and there's no new theory for you to learn over here. If you worked in an insurance company, you already know, right? How you communicate results is something that you already know inherently. So there's nothing new in the sun that you need to learn when it comes to these two chapters. Although diagnostic and assessment of results is something that you need to understand what the diagnostics are and how they impact the book and things like that. So that's the main aspect over there. But from a communication perspective, it's not very, it's not very heavy. It's fairly theory driven and it's fairly light. So you can read on it on your own time, and if needed, we can have another like a class or something like that. If you feel like there needs to be something that you need clarified or something like that, we can definitely have a separate class on it, right? So let's go straight. And with ALM, we're going to do an ALM masterclass. I'll try to get it done in 15 minutes. Hopefully that should
Okay.
answer all the questions about ALM that you have. And that's about it. ALM is something that
Oh,
does not get tested that heavily in the exam. Although it's a very big chapter, it's a very voluminous chapter. It doesn't get tested as much in the exam. It gets asked once every 5 years, once every 6 years. That is the frequency with which ALM questions get asked. So not something that, turns up
right.
super frequently in the exam, right? So, and even if it does turn up, the questions are all pretty similar. It's the same type of question. The answer is also the same type of answer that you have to give. It's kind of straightforward. That's why I'm sorry, you were asking something?
No, no, no.
Okay. All
Some
right.
background noise is there.
So let's start off. Uh, let's assume that we can consider the runoff of claims to be a random process. Now, can you name some of the factors that would affect the uncertainty of reserving outcomes right off the bat? Can you like quickly name some factors which affect the uncertainty of your reserving outcomes?
Uncertainty of reserving outcomes.
Outcomes.
Okay.
So this is only from the lens of the runoff of claims. For example, your modeling technique that you use is not part of this.
Right. So, one would be obviously the emergence of any cat losses or
Okay.
large losses that can affect my reserving outcomes,
Okay.
or uh, any factor that also affects the frequency or severity of my other losses, attritional losses that could
Hmm.
also affect my reserving outcomes.
Okay.
Uh, Other than that, any regulatory change uh, or
Hmm.
any new law passed by the government
Hmm.
that could affect my reserving outcomes. Any unfavorable awards by the courts
Hmm.
that could affect my reserving outcomes. Uh, any change in the OSLR reserves, default reserves, or the way the OSLR reserves are calculated by the company, that
Okay.
may change my reserving outcomes.
Okay.
Uh, uh,
Good answers, in my opinion. Very good answers. And you're almost there. So you can split this answer into a couple of big points, right? And you made a wide variety of very valid answers. This is not the list that I have is not exhaustive. So
Right.
your answers are also right? A lot of what you said is also right. From a factor perspective, you can split the runoff process into three aspects. One is claims, one is environmental, one is operational. From a claims perspective, the occurrence and severity of claim is a random process by itself.
Right.
You also have a random process which falls when it comes to notification and delays of claims. Things like latent claims, things like inflation of claims, these are all, again, factors which affect the runoff process. From an environmental perspective, you hit it on the nail again. Court awards is another example, right? Very important
Right.
aspect which deals with the random process runoff. There is also the changes to litigiousness in society. If there is a
Right.
gradual increase in the ability for customers or the nature of customers to make claims or make cases, that will increase your
Right.
randomness, that will increase the amount of fluctuations that you have. Legislations is another factor which affects this fluctuation that is there. Operational perspective, things that you do internally will also have an impact on how random your process is. For example, changes to claims handling and changes to the way claims are settled are very important aspects in determining whether or not your claims are going to be more random in nature or less random in nature. Clear?
Right.
So why do we use stochastic modeling? And there are multiple reasons to use stochastic modeling. Primary reason, in my opinion, is because we can. That's one answer. That's a valid answer to use.
Okay.
Major reasons to use stochastic modeling is A, assess reserve adequacy. You can test the strength of reserves using stochastic modeling, and you can test the adequacy of margins using stochastic modeling. The
Right.
idea here is that while this is possible, while this is also possible in traditional other reserving methods, with stochastic methods, you have an element of simulation in there, which increases the amount of which kind of quantifies the uncertainty around those reserves. So it's not just testing the
Right.
strength of reserves, it is also testing the uncertainty around those reserves. You
Right.
can also compare different reserve estimates and reasonableness. You can compare results from different dates. You can monitor claim movements. You can allocate capital more efficiently using stochastic models. You can provide the management with more information on reserves using stochastic reserves. So it's not just one moment that you're talking about two moments, right? You're talking about mean and you're talking about variance.
Mean
So
variance. Yeah.
there is more information, and you are also providing more information to investors. You can create knockoff points from here. Not only are you providing more information to investors, you are also providing more information to credit rating agencies, which also have an impact on the share price, which has an impact on ability for the company to draw capital in the market, things like that. Cost of capital impact, all those knockoff effects are there. Okay.
Yes.
What are the pros and cons of stochastic modeling? The pros are very simple. You can estimate the reliability of a fitted model very easily because you have uncertainty of reserves. You know how reliable that model is. You can, because you have uncertainty numbers, you can obtain the magnitude of random variations from the model. You can easily verify assumptions. You gain a better understanding of the entire underlying random process of claims when you use a stochastic model for reserving. You can also build models where data points with large random variations have little influence on final results. I'll give you a simple example. Let's say that you have a basic chain ladder model and there is a sudden spike in claims in one of the development periods. That will definitely have an impact on the ATAFs that you decide and the CDFs that you
Correct.
calculate, which basically means that you need to have a manual intervention in that particular section to ensure that the claims are not too jagged in nature. Whereas in stochastic models, you don't have to do that as much because the nature of the model itself is in a way to eliminate random large variations.
Correct.
From a disadvantage perspective, it is fairly straightforward. It takes a lot of time to build a stochastic model. It's not very easy. It is very complex. It requires a lot of skill and it requires a lot of training. There is more judgment involved and there is a higher chance of errors. So these are all fairly generic points against stochastic model. I would urge you to know these points in and out, because when it comes to a modeling perspective, you can apply these generic points anywhere. These could also be applied to a very complex capital model, for example. Time is another, these are generic points, right? So I would urge you to know these points very, very well and keep them on the top of your hand, because when you are in exam pressure, these points will come in handy when you want to generate points and knock off points. Right? The points have to be contextual, but these are good starting off points for you.
Right.
Why are they two papers? I don't understand this. Okay. One of the biggest problems that you have to deal with when it comes to stochastic models and stochastic reserving models, and not only stochastic models, right? This is again a general modeling masterclass for you. You have to deal with errors. And when it comes to errors, there are multiple types of errors when you deal with modeling. One is model error. The other one is parameter error. Model error happens because models are a simplification of what happens in real life. And we know that real life is impossible to model. So there will always be, every model will have an error, right? All models have errors and you have to deal with them. And model errors are basically the uncertainty in estimates produced by the model. Now, there are two particular errors that you have to deal with when it comes to model-related errors. One is process error and the other is parameter error. Process error plus parameter error is called the prediction error, right? Now, process error leads to process variance. Parameter error leads to parameter variance. So, process variance plus parameter variance equal to prediction variance. Your variance in your prediction, your difference between your actual value and predicted value, is a function of two major components. One is the parameters that have been used to predict the values, and the other is the underlying process. In this case, the underlying process is the underlying claims process, which can be broken into frequency and severity. Clear? So this is how this ties to your SP8 material as well, your SA3 material. Everything comes from that one claims frequency modeling and claims severity modeling.
Right.
From a type of model perspective, there are multiple types of models. There are analytical models. What we have seen till now, your chain ladder, your Bonnet-Ferguson, your ACPC method, these are all called analytical models. Within stochastic models, those are deterministic analytical models. Within stochastic models, you have analytical, simulation, and Bayesian. And we are going to focus on three things. I've mentioned two things over here, but we're going to focus on three things. And the exam that we have looked at also focuses only on these three things, which is the MAC model, the over-dispersed Poisson model, and the over-dispersed Poisson bootstrap model.
Okay.
The others, if you want, I can take a separate class. However, we've not had a question on this. The number of questions, if you see also on stochastic modeling, is very low in nature. There are not many questions that get asked from stochastic modeling, right? I think only one year.
Whatever questions that gets asked, are those more of a theoretical or
very theoretical?
Okay.
Very, very theoretical in nature. You don't get like, some people will not give you, like IFoA is not going to go and give you like a bunch of questions and tell you start doing a MAC model. That's never been asked. Whereas from IAI, there's been a MAC model question. They've asked you to do the MAC model. what I am going to do is I'm going to send you a separate video which details on how to do the MAC model from a
Okay.
basic claims triangle. I'll do that. I'll
Okay.
separately create another video similar to how we were
Sure.
planning for the proof on SP8 that we were talking about, right? I will create
Right.
another video and I will send you the video which details how the triangles are created using MAC. You'll have an
Okay.
understanding of how MAC model is done. If you want to have an
Sure.
understanding of MAC model, very easy way for you to do it is there's a paper that you can study, that you can read through, which gives you the overview of the MAC model. Either that or B, you can go to the exam questions in the back of the chapter of chapter 16. There's a
Okay.
question on stochastic model which tells you to solve the stochastic model, right? That's the MAC model. What they've given the equation
Okay.
and everything. That's the MAC model. One thing is that if they ask you this question, if they ask you, let's say, log normal model in the question in the exam, right? They will actually give you all the equations that you need to plug in. Your job is to figure out how to do the modeling. You understand how to do the reserving.
Right.
So if your fundamentals
Right.
of reserving is strong, you'll be able to figure it out on the fly because the process
Okay.
is the same. It's just what you plug in to get the ultimates is what is different.
Right.
Okay, let's go into the MAC model and let's go look at the assumptions first. Our three main assumptions that we saw in the analytical deterministic models will change when it comes to stochastic models, and that is the biggest change. The first is the same, which is the runoff pattern is the same as origin period. The second is the future development of a cohort is independent of historical factors. This is also similar to what we have assumed. The third assumption is that the variance of cumulative claims in development period T is is proportional to the cumulative claims at T minus 1. I would urge you to learn these assumptions by heart.
Okay.
These are the things that you'll get asked, right? What are the assumptions of the MAC model? Things like that, right? Now, output of the MAC model is you get a best estimate along with standard errors.
Okay.
Clear? You get two outputs of the MAC model. You get best estimate reserves, and then you'll get a standard error around that best estimate. So the MAC model is distribution free. It makes no assumptions on the underlying distribution of the claims, and
Okay.
it assumes only the first two moments, and the output is also the first two moments of the claim.
Okay.
You get mean, and then you get standard error, which is standard deviation, which can be squared to get the variance of the claim. Right? One
Okay.
important aspect is that the MAC model can handle negative increments. What do you mean by negative increments? When there's a paid triangle, there could be negative increments from one period to another because of releases
Right.
in reserves. Even in income triangles, this could be possible, where there's an amount that is there, and then there's a reduction in the amount because of negative
Right.
increment. The MAC
Right.
model can handle negative increments. Some models cannot handle negative increments, primarily the ODP bootstrap model, not the regular
Okay.
ODP model. The ODP bootstrap model cannot handle negative increments. Right?
Okay.
That's something that you have to remember.
Hmm.
The ODP model is similar to the MAC model in the sense that the assumptions are almost similar with one small change here and there. The first two assumptions are somewhat similar, right? The runoff pattern is the same as the origin period. That's the first assumption. The second assumption is that the incremental amounts are statistically independent. The third assumption is that the variance of incremental claims is proportional to the mean. And the fourth assumption is that the expected incremental claims is positive for all periods.
Hmm.
So you look at the difference over here,
Right.
right? Expected incremental claims is positive for all period, which basically means that you cannot handle zero claims.
Hmm.
Generalization, ODP is basically nothing but a generalization of the Poisson model. The
Okay.
underlying claims process is assumed to be a Poisson process, and that's how this model gets built.
Okay.
ODP on its own can handle negative increments, but when you bootstrap it, it cannot build negative increments. And bootstrapping
Actually,
is
I was
nothing.
confused by this
Huh.
because
See, bootstrapping is
assumption
nothing.
sector
Sorry,
assumption section says that incremental claims should be positive for all periods.
correct.
So then, how come there
Expected
is this?
incremental claims. I'll find out more on this. I'll be frank.
Okay,
The amount of material, the amount of data and the material is not very heavy on this. There's only one paragraph.
okay,
So there is a
okay,
white paper that has been written on ODP. Let me go through the white paper and let me give you more details.
sure.
I've not had time to go through it. I wanted to go through it before the class, but I've not had time to go through it. But let me go through the white paper. I've downloaded the white paper and kept it. I need to go through it and I'll understand it and then I will explain it to you. Hopefully by the next class, you should have more clarity on this.
Okay.
Okay. Bootstrap. Now, do you know what bootstrapping is, like from a modeling perspective?
No, no, I haven't worked on this any time.
Okay. Bootstrapping is not it's not like a model per se. It's not a method, but it's more of a technique. And it can be applied to multiple sections, multiple areas. It basically involves sampling multiple times from the observed data, and often it is sampled with replacement. And
Okay,
every time you do, it's a way of creating new data points from an existing data points. Let's say you have 1,000 data points. It's not enough for you to build a model, right?
Hmm.
What do? You keep resampling from the same 1,000 data points and you build like a model with 10,000 data points. How do you do that?
Okay,
Let's assume that you have let's assume you have 25 years of stock returns with you, like, of a company. Now you have to build a Bayesian model or you want to get like a stochastic model built, but you only have 25 years of returns. How do you do it? You get all the past annual returns. You select 10 random different values. You calculate the average returns for the 10 values. Now you repeat this multiple times and you get a distribution of returns from these 10
okay,
values, right? This is called bootstrapping. This process that I mentioned is called bootstrapping.
okay,
Clear?
right,
Questions?
okay. No,
Okay. Now, bootstrapping using the ODP is somewhat similar, right? Think of bootstrapping as using ODP as fitting a GLM to reserves. Instead of using triangles, you're actually fitting a GLM mod to reserves. That's how bootstrapping using ODP is. Think of it simply as building a GLM only for reserving, where you
hmm.
estimate the idea over here, the output over here is the estimation of the ultimates. So estimation of the CDFs. That is what you're trying to estimate for each claim. That's what you're doing with bootstrapping using ODP. That's the whole logic that has been built around here. Very, very unlikely for you to get asked these questions. I would urge you to just read through it once, not become too enamored with there is a paper that is there. I've mentioned the paper here. Go through that paper. It is very heavy reading. I would urge you to not bother too much about this. I would urge you to only know what it is. For example, what is the process of bootstrapping using ODP? The first step is to calculate the expected value of residuals. And for this, you use standard techniques, right? You obtain the fitted values and you subtract the past claims data from that to get the residuals. Then you resample the residuals to get a new triangle altogether. And similarly, you create multiple large number of alternate data sets from these resampled values, and you effectively incorporate randomness in the present data using this. And after that, you refit the chain ladder method onto all these new triangles to obtain a revised estimate figures. And from those revised estimate figures, you'll get the distribution of reserves,
Okay,
right? So it's nothing but resampling and then estimating and then obtaining reserves. Resampling, estimating, obtaining. Resampling, estimating, obtaining. Resampling, estimating, obtaining. After like 30, 40 attempts, what you'll have is you'll have a range of reserves, which is basically part of the distribution, right? This is similar to how we looked at when we looked at bootstrapping the stock returns for 25 years. It's the same process, right? Now, when you have a range of reserves, you have a distribution of reserves, you know what the first moment is, you know what the second moment is. So you know what the
Right.
mean is, you know what the variance is. That's how you get this. Think of it as simply fitting a GLM. That's about it.
Okay.
Right? From one of the major issues that you have to deal with when you're dealing with stochastic reserves is when you have multiple lines. So the idea is, what do you do when you have multiple lines? Do you run the same model across different lines, or do you run different models for each lines, right? We could do we could do modeling for each line of business separately. The problem is that once you model each line of business and once you get the reserve estimate for each line of business, you cannot just simply add the reserves up. You have to account for the fact that there could be dependencies between the two lines, because now you're in the realm of random processes. You're no longer in the realm of just simple deterministic models. So let's say you're running a reserving exercise across different lines and you're using simple basic chain ladder. How do you obtain the estimate for final reserves when you have 4 lines of business? You do basic chain ladder for each line of business and then you add them, right? That's how you do. That's how you get the IBNR figures in your in your company as well.
Sorry, actually, I missed your last sentence, some
I'm
network issue.
saying let's say that you're the reserving actuary of your company and you guys engage with 4 lines of business
Hmm.
and you build 4 basic chain ladders.
Right.
Now, how do you get the IBNR for the company? You just add the figures, right? Add the output of the
Correct.
chain ladders.
I add the output of the chain ladder. Yes.
Yeah. However, when it comes to stochastic models, you can't do that because you need to account
Achha.
for dependencies.
Right.
Now, you can add them if you assume that the lines of business are independent of each other.
Independent of each other.
Correct. However,
Correct.
can you tell me why the lines of business or origin years could not be independent? There are some reasons why they could not be independent. Under what circumstances could the lines of business be dependent on each other?
So one circumstance could be that let's say a single cat event may
Okay,
affect multiple lines of business.
good.
For example, fire or motor.
Very good
Uh,
point. Very good point.
uh, then
What is the knockoff point of that? There is a knockoff point from that.
mm, can't think of that.
Figure out who's going to handle the claims.
Okay, so the claims team may be common between lines of business.
Yes,
Uh,
that is the knockoff point. So
right,
it's not just that they are affected by the same events. They could
right,
be handled by the same team, which means that the same team will have the same amount of bias.
right,
Whatever bias is there in one line will also be there in another line,
right.
right? All right.
So
Good.
same thing could be said about the business as well, right?
Yeah,
Maybe a same person is handling the both the lines of business, and maybe that
possibly.
person could be aggressive in nature or conservative in nature. That may affect both the lines similarly.
In what way are you talking about? Are you talking about like business
So let's
volumes?
not only volumes, the pricing, for example, if the
Yeah,
pricing actually is say let's say same, and he is very aggressive, who prices everything aggressively.
Right.
So all the lines will be aggressively priced. So that in that way also. Uh,
So
so
that
like
kind of yes and no to a certain extent. It kind of, when it comes to things like pricing, there is an element of business vision that's involved as well, right? Let's assume that the actuary is an aggressive actuary who prices aggressively. The answer that you're providing is correct only if there is a huge amount of independence of that actuary. For example, let's assume that the board of the company is not aggressive on one line, but they're very aggressive on the other line.
hmm,
The management will say, okay, I want the prices for this line to be aggressive, but for this line, I want it to be conservative. The final
right.
answer for, you have to understand there is a principal agent problem here, right? The principal
Hmm,
here is the management. The agent is the actuary here. So the actuary might be aggressive, but at the end of the day, you have to understand who has power of claims to influence, who has power of something to influence that figure. We cannot
yeah,
influence the
then
single premiums without
so
sign
this
off from.
point then can be extended to the senior management then.
Yes, senior management is a good point. You're making a good point over there. If the senior management is aggressive, then you are right that bias will be there. You're right. And it's not only from a reserving lens, it's also from a pricing lens.
Yes, all the lenses. Yeah. Because at the end, the way you price may also impact the reserve, the way you reserve.
Correct. Exactly. Exactly. You're absolutely right. It impacts what reserves you create. It impacts how you create the reserves.
Exactly.
So you're right. You're absolutely right. More points which are there, which is one one common point which you can generate problems in data. The same data problems could exist across multiple lines of business, thereby creating dependencies. Inflationary
Right.
trends might affect more than one adjacent origin period, which could create dependencies. And
Right.
legal changes could affect several lines of business. Perfect example, third party liability for motor, workers' compensation, employer's liability. All these are affected by pretty much the same court award.
Hmm.
So if there's a
Correct.
court, huh, what was your question?
No, no, I was just agreeing to the point.
Okay, okay. Clear?
Yes, yes.
All right. And let's look at the most common issues when it comes to uh, stochastic modeling. The biggest
I
issue,
had one question.
huh,
So how do we handle this dependency? So is there
uh,
anything in the material on that?
there is
So
nothing in the
let's.
material. No, there is nothing in the material, but there are a couple of ways that you can handle dependencies. For for the first point, right? They are impacted by the same events. Sadly, you cannot do it. There's no way for you to handle the dependency.
Hmm,
If there is a
hmm,
catastrophe event and if multiple lines of business are impacted by that, no way for you to do it. The only way you can think about doing it is by completely diversifying your portfolio, which is theoretically impossible.
right.
Diversification of portfolio is the only answer to that, but that's theoretically impossible, right? You can't have a fully diversified portfolio. You will have some concentration
Correct.
somewhere. So
Correct.
that's one. It's a systemic risk for every insurer. With respect to
Correct.
same team handling claims, straightforward method of handling this is to have different team handle different claims. The
Correct.
problem with this is that you will have a higher cost because you have more personnel and you'll have a lower utilization. Perfect example.
Correct.
Let's say that you only have 100 professional indemnity policies and you have 20,000 employee liability policies. Now, do you want to have a separate claims handler only for 100 professional indemnity policies? It's not practical.
Hmm,
However,
correct.
so it's these dependencies are injected because there is some practical material problems that the insurers face. Otherwise, they would not do it, right? There is an
Correct.
underlying reason why this is, right? Same team handles the claims. Obviously, the best way is to have separate person handling separate things, but it's not practical. It's not material. Legal changes, again, completely out of the hand of the insurer. You have no control. The only way you can think about, realistically speaking, not even realistically, right? Theoretically speaking, the only way you can possibly handle this is by lobbying with the government, which is also another impossible thing, especially from an Indian context. So it's completely out of the it's out of the question, right? So legal changes
Hmm.
is something that there is no way for you to handle. Problems in data can actually be very easily handled by having better QC checks from the point of inception of the policy to
Hmm.
having a more robust IT system in place. If I have better
Right.
QC checks and if I have more robust IT systems, I'll be able to minimize the amount of data issues that the company has, which automatically reduces dependencies, which automatically improves my data quality. Inflationary trends, one way of doing this is to identify separate inflation indices that you can use to de-link whether or not you're using the same inflationary assumption across multiple lines of business.
Hmm. Right.
Today, in your company, do you use the same inflation number everywhere?
No. No.
You don't, right? Where,
No.
what do you do? How do you treat inflation when it comes to reserves?
So, for example, so one way is so let's say health. So
Hmm,
health is more impacted by the medical inflation
correct,
and very less affected by the wage inflation, for example.
correct,
But a line like workman compensation or motor TP will get more affected by the wage inflation
correct.
rather than the general inflation or the
Hmm,
medical inflation.
hmm,
Or a line like motor OD will
hmm,
have a more impact of general inflation
hmm,
uh, or some specific inflation related to auto parts and everything.
hmm, hmm, hmm. No,
So all this may have
that's correct. My
uh,
question to
yeah.
you,
So one way to calculate this inflation is to see how the paid severities are moving year on year for a homogeneous line of business for a
okay,
homogeneous cohort.
okay.
So that is one way to uh,
No, that's
calculate the
right.
inflation. The second
My
way would be
question is
the
different.
statistics. Yeah.
That's not my question. My
Okay.
question is, how are
Okay.
you guys in your company right now handling inflation?
So there is no specific assumption needed
Hmm.
for reserving because my claim triangles I am not adjusting for the inflation. So
Okay.
there is an implicit inflation already built in my patterns.
You're basically saying that you are assuming that the weighted average inflation that you're seeing in the data is a good indicator of future
Right.
inflation.
Correct. Correct.
So
Correct.
you're not inflation adjusting your chain ladders.
Chain ladder. However, for motor TP line of business, we have an explicit inflation adjustment
Hmm.
on severities because so in motor TP, my recent quarters are since it is very less developed, we
Okay.
can't rely on those developments, and hence we use frequency severity method,
Okay.
wherein for severity we inflate the let's say if I assume that severity 3 years back is a right indicator, then
Hmm.
from there I inflate year on year what would be my current severities, and based on that I uh, project the ULRs.
Okay. Fair enough. And why do you, there is also another reason. It's not only the fact that the recent quarters are less developed. The recent quarters are less developed for every line of business, right? It's not just motor. Every line of business.
At least for short tailed your even your latest quarter would
That's
be
fair.
around 70-80% developed. Yeah.
That's fair. But let's say professional indemnity. Let's take.
Yeah, agreed. So TP was just an example. Yeah.
There is another reason for that, and the other reason for that is that court award inflations are very unpredictable. So
Right.
the logic, they there is one logic over there, right? The logic over there is that you are right. Your point is right. The latest cohorts are not fully developed, or not even on fully developed, right? There's no development whatsoever in the in the latest cohorts that you have. Secondly, future inflation of TP claims cannot be assumed to be a weighted average of past inflation. And the reason for that is court awards.
Okay.
Today you have
Uh,
Rajesh versus
but
Rajbir.
can't we say that historically,
Hmm.
my historical past quote awards are part of my triangles,
Huh.
wherein, let's say, if there was a quote award with a delay
Hmm.
and it impacted retrospectively,
Correct.
then that is also forming part of my triangles and my patterns. So,
It is.
in a way, partly it is considered, obviously.
That is true. That is true if you can use past court awards to predict future court awards.
Agreed. But at least those will lead to
You are
inflationary
right.
increases.
Yeah, you are right. It will lead to inflationary increases. The problem
Yeah,
is
yeah.
that you are not in a position to use past inflationary data to predict what the
Correct,
future is
correct.
going to be
Because we
only with
never
court
know
awards.
whether the future quote awards would be more aggressive or more less
Correct.
aggressive.
Exactly. You don't
That we
know.
don't know.
You don't know it.
So for
Uh,
that we generally have additional margins built in on the
yeah, that is
recent
the
years.
reason why you do that exercise. Yes, that is the logic.
Correct.
Okay. So from an issue perspective, it is fairly straightforward. It is very clear. Major issues that you have to deal with, and this is like a good theory question that can come out. What are the major issues? And one of the most important points that you have to realize or understand with stochastic modeling as a whole, it's not just stochastic reserving. It is with stochastic modeling as a whole, right? Even with pricing, even when you do any data model that is there, anything that you have to do with, you have to talk about extreme values.
Hmm.
Extreme values is a
Right.
major issue when it comes to anything to do with stochastic models, primarily because extreme value data points are not very readily available.
Correct.
And extreme value data points are not readily generated.
Hmm.
If I have a model with a mean and variance, 95-96% of my generated values is going to be within 2 sigma of the mean and variance, correct?
Hmm. Hmm.
Which means if I want like a 6 sigma deviation or a 7 sigma deviation,
Right.
I have to generate you imagine the number of data points that I have to generate one 7 sigma variation data point.
Right.
So the distribution will always have a problem in generating the tail of the
Right.
generator. The random number generator will always have a problem in generating the tail of the distribution.
Right.
So
Even the mean and variance are, since it is calculated from our data itself.
correct.
So hypothetically, if my data have the maximum claim amount of, let's say, 1 crore, but that doesn't mean that
Yes.
claim amount of 10 crores is not possible.
Correct.
So if
Correct.
I only use that data for calculating mean and
It will
variance,
result in a
my
problem.
output will never have high claim amounts,
Absolutely.
basically.
That's a major issue. Absolutely. That's a major issue. And and it also, the exact example that you quoted becomes a major problem in projecting ENIDs, events not in data. You only have a data with a
Right.
cap of 1 crore. However,
Hmm.
you know for a fact that there could be claims for say 7 crores or 8 crores because of how your portfolio is structured. You will not be
Hmm.
able to generate extreme values in your this thing, right? So that's
Right.
one major thing. A second thing is that it has been proven that stochastic models often underestimate variability. There is a
Hmm.
consensus that methods often underestimate the variability, and the historical data, that's because the historical data might not capture all sources of variability.
Right.
You have claim data only for certain events, but you don't have claim data for all events, right? You know it by sight.
Hmm.
There are latent claims that are there, which means
Right.
that the variability that you're estimating is already underestimated to the true variability that is there, no?
Right.
So it is important to use judgment when you are doing any calculations using stochastic model around variance, because you have to understand that variability is underestimated. It's what the variance that you're seeing is not the true variance. The
Right.
variance that you're seeing is the actual variance is higher than the true variance. You have to, it's a life lesson that you have to learn. It's
Yeah.
also
Yeah.
a life lesson that when you look at mean and variance, the variance is a very, the variance that you see, is it a true variance, right? And this is a major issue
Right.
when it comes to stock markets as well. When you're investing,
Right.
when you're when you're building your asset portfolios and things like that.
Right.
The question, a lot of people will see greed. The there's a lot of hot hand fallacy that goes, right? That
Right.
stocks have been on the up for the past 5 days or 5 weeks or 5 months, and it will continue to go up because they haven't seen variance. The problem is that
Right.
the variance that they've seen has not captured every event that can happen, and
Right.
that could lead to a lot of market crashes. It could lead to a lot of losses if they are not in a frame of mind to have clear investing rules. So this particular problem that we are stating, it's not related only to reserving. And in fact, this entire discussion that we've had, it's not related only to reserving, it's related to every aspect. You can plug this into every business, every line of every vertical, every horizontal, and it'll probably be very applicable, right? The
So
third,
ENID issue will also be valid for your deterministic models as well, right?
yes,
Uh,
definitely,
because if in normal CLM, let's say there are no
definitely,
claims with 10 quarters delay till now, that doesn't mean it could never happen again.
definitely. ENID is a problem everywhere. Yes, you're right.
So in any deterministic or CLM model or any questions where they have asked for any assumptions or something, we
Ah,
can produce this point, right?
you can,
That
you can produce this point. Uh, one one suggestion I'll make is nuance it a little bit. Use judgment as to whether you want to produce that
right.
point.
But yeah, depending on the situation. Yes,
Yeah,
yes, yes. Depending on
depending
the
on the
situation.
situation, you're absolutely right. I would urge you to put that point, but nuance it a little bit. Use judgment.
Right. Okay.
Does the question talk about teenage? Does the question not talk about teenage? Because
No,
if it
not only in it, I'm
ah
about
no, no, I'm
anything. Yeah.
saying if the question has no connection to innate, you can put this point,
Correct.
but
No, yeah, agreed. Agreed. Agreed.
might not earn you as much. They'll be you should over engineer the assumptions. You should
Correct.
keep it as close to the problem statement as possible. Uh,
Right.
Next problem, with respect to stochastic model, obvious problem, sparse data.
Yeah.
Problematic. If you don't have data, you will not be able to run the model. Even if you have data, sometimes small changes in the data can lead to large variances. You
Yeah.
could get highly sensitive results. You can have missing and erroneous data. Even when you have data, for example, gender is a very common problem that many people face. You'll have
Right.
males, you'll have females, then you'll have blanks. What do you do with the blanks? Do you put them under male? Do you put them under female? It's a big problem that many people face. Simple
Correct.
problem, but it gets complicated because if you don't have a logic for that, your answers are going to be whack. Your rating factor will be screwed up, things like that. Right now, you cannot use gender as a rating factor. That's a different issue altogether, but at least you understand the scenario over there. Model forms is another problem. There could be a mismatch between the model used and the underlying data. I'll give you a simple example over here. Let's say that you are modeling claims frequency and you use a gamma distribution. You use a model with a gamma distribution. You're not going to get the answer. I'm giving you an extreme case to make it easier for you to understand what it is, right? Because claims frequency follows a Poisson distribution,
Right.
right? So
Right.
you cannot use a model form which does not fit with the underlying data and expect the same
Correct.
results. You will get different
Correct.
results. And with stochastic modeling, especially for reserving, that is a major problem because there will always be mismatches between the model and the underlying data. right? Each model has its own limitations. You have to understand what the limitations of each model are, if you're using Mac model, if you're using ODP, if you're using bootstrapped ODP, you have to understand what the limitation of each model is, and then you have to accordingly treat it. One of the biggest problems is also negative increments. More often than not, models handle negative increments, but for example, the bootstrapped ODP does not handle negative increments. So generally speaking, it's okay for paid modeling. It's not okay for incurred modeling. You have to use a lot of judgment when it comes to model forms. So that's one aspect that you have to understand. And finally, latent claims, like we have already discussed, data is not available, which basically means that all stochastic models, not only all stochastic models, but this is also true for deterministic ones as well. They are not good at predicting latent claims. And this is often a major source of error for stochastic models and deterministic models. Clear?
Right. Okay. Yes.
All right. Let's quickly move to diagnostics. Right? What are diagnostics? I'm going to spend only maybe 10 minutes on this. I'm not going to spend more time on this because we've already done questions on diagnostics in our previous class, right? Nothing new. There's nothing new that we are going to kind of deal with. Although I wanted to run one question by you just to ensure that you have an idea of what is. So I'm going to give you an introduction to diagnostics, and we're going to have one conversation on what some diagnostics are. Tools to measure, right? So it's a measure that is used to assist with interpretation of data to help us test and verify an underlying set of assumption or methodology. That's what the definition of a diagnostic is. What does it do? It helps to identify reasons for changes in time, and it helps us to highlight unusual features. Clear?
Can you elaborate a bit on the definition?
Yeah, nothing.
Tool or measure?
It's nothing, right? So it's just a measure that will assist you with interpretation of a data point or a result, and it'll help you tell whether or not your underlying assumption or methodology is correct or incorrect. That is the role of a diagnostic.
Okay.
It's a fairly simple
Understood.
thing. Are you correct? Are you directionally incorrect? That's what it's trying to tell you. It's a compass that you can use.
So, for example, if we see year-on-year loss ratio trend, so that is nothing but
Exactly.
diagnostic.
Yes, perfect. That's a good this thing. It's a good segue as well. Can you tell me what some diagnostics could be? You already mentioned loss ratio as one diagnostic. Can you mention others?
One could be changes in severities.
Okay, good.
Or change.
Correct.
Or trend of frequencies. Any changes in frequencies.
Correct.
Uh, any specific event that is impacting the frequency of any particular cohort. For
Correct.
example, COVID.
Frequency and severity. No, frequency and severity. You are there. Next point.
Then
I'll give you one example. Paid to incurred. That's a diagnostic.
yes.
Paid to incurred ratio. That's a diagnostic. So similar to that, can you tell me other diagnostics?
One could be outstanding to incurred ratio.
Good.
Then one could be your IBNR to earnings ratio.
Good. So can you tell me IBNR to incurred? If it is increasing over time, what does that imply?
It implies that there is a delayed reportings. The delay in reporting is increasing basically.
Can you elaborate it a little bit?
So if my IBNR to incurred is increasing, which means that my ATUF is reducing. So,
Hmm.
uh, so my actual to ultimate factors are reducing, which means that we are now expecting more delayed reportings in future for that particular cohort than it was in previous quarters.
You are expecting delayed reporting in the future cohorts.
So, for example, my last cohort was incurred to IBNR to incurred ratio was, let's say, 10%.
Okay.
And for the same delay, now after a year, my
It's
recent quarter
15%.
is showing, let's say, 15%. So if that percent has increased,
Hmm.
which means that I'm expecting more claims in future for that latest cohort as compared to what I was expecting for my last cohort at the same
Correct.
delay, basically.
Correct.
So, so my patterns have slowed down, or my claims
Correct.
reporting have been delayed.
But how is
Uh,
claim reporting delayed over here? Oh, yes,
because
yes. Okay, okay. Because you
we are
are
expecting more IBNR,
fair
right?
enough.
So
Fair
my
enough. Fair enough. It's a solid answer. Any other diagnostic?
other one could be my the proportion of claim handling expenses to the claim incurred.
Good. Good answer.
Uh, one could be the burning cost trends.
Okay.
So my claim amounts to exposure basically.
Okay.
And one could be actual versus expected. So, for example, what are my expected claims for current year
Good.
basis my last year's pattern
So actual
against
versus
what
expected.
actually we have received?
All
Yeah.
right. Actual versus expected is a separate section altogether, right?
Okay.
Actual versus
Okay.
expected is something that you have to do like regardless of what it is, right? It's not only a diagnostic, it's a section altogether. It's a principle altogether. So
Right.
you're right. Yeah, I have only given a subset of all the diagnostics that are there. There are hundreds of diagnostics that are there. What you said, almost everything that you said is right. You have not said anything that is, absolutely incorrect in my opinion. 99.99% of what you said is right. Loss ratios, paid to incurred, case estimate to incurred, average outstanding case to case estimate, IBNR to case estimate, IBNR to incurred, IBNR to paid. You can create how many ever combinations that you want. All these are diagnostics. And
Right.
you have to understand how or what is the impact of these changes on everything. So another exercise that I'll give you, right? What happens if there's an increase in IBNR to paid? We talked about IBNR to incurred. Now, what happens if IBNR to paid is increasing? What does that mean?
Uh, again, it that there could be two reasons. One, that IBN ER is increasing or
Hmm.
IBN YR is increasing.
Okay.
So IBN ER will increase when your outstanding, the way the outstanding is kept has changed,
Hmm.
or the claims team is keeping lower outstanding amounts.
Hmm.
So while but your paid will remain the same, but your IBNR will increase
Right.
because the outstanding is lower.
Right. You're
And
you're basically
similarly,
you're basically updating your case reserves.
updating the cases as well.
Yeah.
So that will form part of my IBN ER. And next would
Correct.
be another reason could be IBN YR,
Right.
which means that delayed, there are again delayed reporting.
Right. Good answer.
So
It's a good answer. It's a good answer. The fact that you split IBNR into IBNER and IBNYR is a very good answer. That's how you go. That's how you think, right? You break the
Yeah.
answer down into multiple components and then you think how that impacts. So when it comes to diagnostics, a lot of the questions will be around these small things, right? How does this impact that? How does
Right.
this impact that? So you have to think through all those aspects. One more important thing that you missed is RI to gross. That is one important
Right.
diagnostic that is
Right.
there.
No, no, I it
Pretty sure you
struck
know
me
it.
as soon as I saw this. Yeah.
Yeah, pretty sure you know it, right? And then there is
Yes.
also survival ratios, which is again like a definition. Claims frequency, average claims, you got it, right? I don't think
Yeah.
that there is anything that we need to kind of go into these details, but understand that the questions that you get asked will also be around these kind of questions, right? You have to,
Mm.
it's more on application of the theory and not the theory in itself.
Right.
Right? What I will also do separately is for each of these metrics, I will create a separate whimsical and I will give it to you so that it will be easy for you to kind of go through it and revise, and we can, if required, have a discussion on it separately.
Sure.
Okay. All right.
Yep.
Quick question. Let's say that you have a development triangle of paid claims split by accident year. Can you suggest possible reasons for a row of figures that are unusually high, B, a column of figures that are unusually high, and C, a diagonal of figures that are unusually low?
Okay.
So let's go one by one. A row of figures that are unusually high.
So paid claims. Okay. Yeah. So a row of figures that are unusually high. So one reason could be the volume could be high. The
Okay.
business return would be high. So correspondingly, your overall payments, absolute payments would be higher than your other cohorts.
No, but this is accident year, no?
Yeah, yeah. So for example, if in that year the volume you have written is much higher than the other years,
But it takes 6 months or it takes one
but
year
the loss
to
ratio is same.
earn. Yeah. It takes time for me to
No,
earn that
so
volume, no?
yes, but hypothetically it could
Let's say
have
I
higher
write it.
earnings in that year. So I am saying that the earnings are higher in that year in that row.
You're saying
So
that I have
uh,
previously written more business and then I'm earning that business this year.
for whatever reason, or you could have written the business on very high business on 1st April. So
Okay.
your accident is overlapping with your underwriting. It could be any reason. For any reason, if my earnings are higher for that row,
Hmm.
then my paid claims would be higher in that row. Absolute paid claims would be higher for that row, but that
Okay.
does not necessarily mean that my loss ratios are higher.
Fair enough. Fair enough. We are looking at
Uh,
overall business. Okay. Fair enough.
yeah.
What
Second would
other
be
reasons?
if that cohort has been hit by any major cat event.
That is a better answer, actually.
Yeah.
To me, that is a better answer than
Okay.
the previous answer that you made, because the previous answer, in my opinion, is a little weak.
Okay.
It's a little weak. You are right. You are theoretically correct. I'm not saying
Yeah,
that you're incorrect.
theoretically. Yeah.
You're theoretically correct, but to me, it sounds a little weak,
Okay.
right? The reason for that being that had it been an underwriting year, had it been paid claims by underwriting year, I would have accepted with your answer.
Right. Okay.
Because underwriting year is the way where you have to deal with this particular problem, right? The fact
Right.
that you have said that the fact that it's mentioned it's accident year, to me, when you say that you are earning more, that kind of, or you have booked more volume, that kind of does not grate well with me,
Okay. Okay.
right?
Got
So
it.
the other, you have to understand that when you're talking about accident year, you have to talk about the same risk environment, right? So effectively speaking, when you go from one accident year to the next, you're going from one risk environment to another risk environment, which means that you have to
Right.
talk about what is changing in the risk environment.
Right.
Okay. Second,
Hmm.
column of
Okay.
figures that are unusually high.
Column of figures that are unusually high.
So there is a spike.
So, which basically, uh, because it talks about the entire column is high, right?
Yeah, the entire column is high.
So then that generally means that that is where the major claims usually gets reported
Okay, good.
or paid. So
Or
that
paid,
is the
yeah.
delay where yeah. The maximum claims are paid at that particular delay, basically.
No, but why is there a spike?
Mm, One reason could be, let's say, a court award. There is a court decision against the company
No.
that could lead to a higher payment, maybe.
If there's a court decision, then it will not affect
But
the
it will
column, no?
only entire column, yeah, exactly.
Yeah.
So it will affect only one cell. Why would it affect the
In fact,
entire column?
I would argue that if there's a court award, it will affect all the rows after that court award, but not before.
Yeah,
Retroactive.
not before, not before. Yeah. Can't think of anything else.
So it could mean that one potential thing could be releases in reserves, over reserving
So
and under
because
reserving.
this is a paid, but because this is a paid triangle, that shouldn't impact your paid triangle, right?
That shouldn't impact your paid triangles. Oh yeah, you are right. You're absolutely right.
So it could only mean one thing, that is
Basically,
where
this means
basically
this
the
is
majority
effectively,
claims are paid. Basically,
this is
that
effectively,
is the
yes.
approximate
You're,
delay where major claims are
this
paid.
is
That's
effectively what you're saying. What this is saying is that a not only is a majority of claims being paid in that particular year, right? There is
no,
a
that delay. So, for
in that
example, if
delay.
this is the fifth column that is very high, which
Correct.
means that
Exactly. This
more
is
or
the
less
fourth
during the
development
fifth
period.
delay, so there is during the fifth period, maximum claims would be paid, basically. Other than that, I can't think of anything else. I don't know. Hello, am I audible?
Yeah. Yeah. What were you saying? Your voice
Yeah.
broke.
Other than that, I can't think of
No,
anything
that
else.
is that is the actual answer that is there in the back of the this is a question in the book in the combined
Acha,
material pack,
okay.
right? So
Yeah.
in my opinion, I like their answer is very a little off, right? They're saying that development year unusually high, there is a spike in settlements, right? So that is
Yeah.
that's the answer that is given. But you are right. There
Yeah.
is something off on this. Let me find out and let me come back to you on this.
Yeah. Yeah.
Okay. Third point, diagonal of figures that are unusually low.
Right. So there could be, I think, multiple reasons.
Hmm.
Uh, so one reason that we have practically experienced was the lockdown,
Perfect.
where no courts were working, so there were no payments, claims were not getting reported, so there were no payments. So that
Perfect.
will affect the entire diagonal.
Perfect. That's a great answer. That is the answer.
Yeah.
Right? Payments impacted for the insurer across the whole calendar year. And
Yeah.
one reason could be pandemics. One reason could be
Yeah.
strikes, or could also be
Correct.
new system implementations, right? I'm implementing a new system. I will delay my payments until my new system is implemented.
Yeah,
Simple.
or if there is a festive season, for example,
There's a
where there
festive
are lots of
season.
holidays.
Correct.
Yeah.
There's a holiday, payment is delayed.
Yeah.
So you'll see
Yeah.
The thing is,
Banks are
holiday.
on strike. There
No,
could be
that's the
anything.
thing. The holiday thing is not going to impact the entire diagonal, by the way.
Depends. So if it is a, let's say it's a
Yeah,
monthly cohort, then it may, yeah. If it is a yearly, then it may not.
yeah, right. So even quarterly, it may
That
not.
will
So
depend, yeah.
yeah, even quarterly, it may not, because holidays is just
So quarterly also, so for example, this October to December quarter, there are lots and lots of holidays in India, for example.
good point.
So at least that is a practical problem that we see.
Good point.
Also, the last quarter, so last quarter, where we see a sudden surge in payments
Hmm.
because people or companies want to clear all the dues by before March end.
Correct. Good point. Very good point. By March, and they want to clear it, and there'll be like a speeding up of the triangle.
Correct, correct.
Good point. Very good point. Fair point. Which brings me to a good segue, which is the reserving cycle, right?
Hmm.
Now, what is the reserving cycle and how is it linked to the underwriting cycle? Do you know what a reserving cycle is?
Never heard of this term, honestly.
Okay,
So,
good. All right. So a reserving cycle is effectively a linkage between the underwriting cycle and claims development. And the theory is that it is highly correlated with the underwriting cycle. And what happens is that in the soft market, claims tend to develop slower, and in the hard market, claims tend to develop faster.
okay,
So what happens is that in the soft market, more often than not, insurers impact the TNCs of the policies. They weaken the TNCs.
right,
They do that to reduce the premiums, right? So what happens is that
right,
they tighten the policy conditions, they weaken the benefits that are offered in a bid to control claims and in a bid to reduce premiums. Now,
right,
increasing or tightening the terms tends to create disputed claims in a soft market, which leads to more claims being contested, which leads to more claims being delayed. It could also be that
right,
tighten
okay,
conditions. The moment I tighten conditions, it means that the surveyor is going to take a longer time to determine whether a claim is payable or not,
right,
which creates delays. Also,
right,
there is also a theory that during soft markets, there's more conservative approaches to reserving than in a hard market.
okay, yeah,
In a hard market, premiums are coming in left, right, and center. And I will happily, reserve whatever I want to reserve and just go along with it. Whereas in a soft market, my
right,
profitability is in question, which means my reserving has to be more conservative,
right.
right?
So,
So
just
one,
for my clarity,
huh,
soft market is something where when there is a slowdown, right?
no,
Uh,
when premiums are dropping, that is your soft market.
okay, okay. So
Premiums are
when it gets
dropping,
competitive, okay,
it's
okay,
getting more competitive. Is
okay.
the soft market. Hard markets is when premiums are rising.
Hmm.
Okay. Uh, so what happens is that in a soft market, because claims develop slower, unadjusted positions underestimate claims. And vice versa, in a hard market, because claims develop faster, unadjusted positions overestimate claims. So it's a very
Okay, okay.
theoretical concept that is there, right?
Hmm.
And where is it most noticeable? It is most noticeable in long tail lines of business.
All right.
Okay. I'm going to take the next 15 minutes to go through one mnemonic which is going to be useful for all ALM related questions. Every ALM related question you can draw from this one mnemonic, right? It's called adverse
Okay.
suntan corrector. So tomorrow, when you have an ALM question, you can just write from this one mnemonic and you are golden. You don't have to bother about studying that ALM chapter. It's like, I think it's like 80 pages or something, if I'm not mistaken, right? Don't study it.
Oh, okay.
Do not study
Okay.
the chapter. You're not going to learn.
Okay.
Have you done ALM in your organization? Have you done ALM for your company?
Yes, I am doing it currently.
You are doing it. So you already know the
Yeah.
material. You already know what ALM is. You already know everything to do with ALM. That chapter is a waste of time,
Okay.
right? It will suck you in, and there's nothing material in that chapter that you already don't know, that anybody who's worked in insurance already don't know. There's nothing in that chapter. So my recommendation to you is to look at only the mnemonic and look at a couple of past question papers on ALM. And by the third or fourth question, you will understand how to structure an ALM question.
Okay.
Okay. Can you tell me what are all the factors that could be for this mnemonic? Like you've done it before, which means that you know what are the major issues around assets and liabilities, right? So what are the factors that could be part of this particular mnemonic?
Mm,
Okay, A is nothing but accrual of liabilities. T is tax. S is size of free assets. So think about it.
so this mnemonic is related to the issues in ALM or overall ALM?
Could be overall ALM issues in ALM. Everything can be
Everything
drawn
combined.
from this.
Okay.
It's a you can, if you talk about issues in ALM, you can probably pick up every point here and you can talk about issues in ALM. Chalo, I'll do one thing because it's a new mnemonic for you. I will go ahead and I will show you the answer. We'll have a small discussion on it and we'll close this class. Right?
Okay. Yeah.
Simple. A is accrual of liabilities. D is diversification. V is valuation of requirements. E is existing portfolio. R is restrictions. It could be legal, environmental, statutory, whatever you want restrictions. S is size of free assets. E is economic outlook. You then have solvency requirements, uncertainty of liabilities, non-investable funds, tax, availability of assets, nature of liabilities. And then you have currency of existing liabilities, other insurers, appetite of other insurers, risk appetite of your own insurer, reinsurance, expenses, credit rating, term of existing liabilities, objectives, and return on free assets. When I say objectives, I'm talking about investment objectives of the company.
Okay.
Now, if you want to talk about issues related to liability ALM, can you pick up a couple of things and talk about issues from this?
Yeah. So one issue would be that the the assets of duration that matches with my liability may not be available in the market.
Perfect. Second issue,
Uh, Second issue would
just pick
be,
any point. Just pick any point from here and talk about it. The first point that you picked was term of existing liabilities. They have to be matched to the assets.
so
That's one.
term and A also availability of assets both
Yeah,
combined.
you just combined it. Second point,
Yeah.
combine something else. Issue. Tell me an issue. Currency.
Yeah. So the liability could be in multiple different currencies. So
Perfect.
the relevant assets of other currencies may not be
Has to be
available,
matched. Simple.
has to be matched or may not be available.
Simple.
Or
I'm telling you,
yeah,
every point that you can think of will be in this one mnemonic for ALM.
right,
This is your ALM masterclass. You don't have to,
right,
if you mug these points up, you're in my opinion, you're good for ALM. You don't need to bother about anything else.
right, right,
Availability of assets issue. Your amount of assets should be immediately available. Otherwise, it becomes a liquidity strain on the company. Simple point.
right, right,
Nature of
right,
liabilities. Nature of liabilities is another issue, right? You have to account for the fact that you have long tail liabilities and short tail liabilities, right?
correct.
So at this point, it's just your exam technique at play.
Correct.
right? Can you take these points and generate relevant points is the only question that you have to answer. That's it.
Okay.
Right? Existing portfolio, mix of the current portfolio is an issue. Again, how do you
Right.
connect mix
Right.
of portfolio to issue in ALM? That's all. Right?
Okay.
Most of the answers that you have to answer are going to be contextual in nature. I didn't have enough time to put these questions, but what we will do is the next class, I'll try to schedule a class tomorrow as well. I don't know if that will be
Okay.
possible because I'm traveling. So
Okay.
I have allocated only one class for tomorrow. However,
Sure.
I will try to schedule next maybe a half an hour class tomorrow. And what we will do
Okay.
is we will go through the ALM questions once and we will see
Okay.
how this can be plugged into the ALM question and we'll close with that because ALM beyond this, let's not go into ALM and things like that. We've finished reserving. We have completed ALM. We've completed the first part, which is the insurance products and general environment and all those things. So a major chunk is completed here. The only two chunks that are that will be remaining after today is going to be capital modeling and finance and accounting, right? I'm
Okay.
going to take finance and accounting first and then capital modeling last,
Okay.
right? Finance and accounting is like what do you say? It's like it's like a very fun chapter, I would say, but if you don't know it, you'll get stuck very badly.
So is it more about accounting standards and stuff?
No, it's a proper. It's not. I mean, yeah, accounting standards is one aspect, but you are not going to study IFRS 17. IFRS 17 is not in the purview of the exam. IFRS 17
Okay.
is
So it is
about
an
essay
essay, I
3.
guess. Yeah.
Yeah, it's an essay 3
Yeah.
paper.
Okay.
This thing, it is mostly to do with how do you deal with UPR? How do you calculate? Once you calculate, so the output of the reserving exercise will give you OSCR, IBNR, UPR. How do you plug that
Mm.
into your balance sheet? How do you plug that into all your calculations for your
Okay.
income statement? How do you create a revenue account? How do you create a profit and loss account?
Understood.
That's the whole process of this thing. And then more importantly, how do you interpret the numbers
Yeah,
from?
that's fun.
Huh?
That's fun.
That's a lot of
That's
fun.
fun.
That's a lot of
Yeah.
fun. I know, I know. So I've been waiting to do that. I wanted to do that initially, and then I realized, no, let's not do that. Let us go. Let us go step by step, right? So the thing is, if you know it, and if you get an accounts question, like a 10-mark question, you can solve within like 7, 8 minutes easily.
Right. Right.
You don't need to
Yeah,
do
but
much.
the practical experience helps with that.
Practical experience
So
definitely
because
helps, but it's
yeah,
just
yeah, because we
practice.
look at the P&L and
Ah,
balance sheet
no,
day
no,
in
no.
day out.
So
So obviously that helps. Yeah.
that's correct. You're right, but this is also practice. Just practice also helps.
No, yeah,
If you
agreed, agreed. Yes, yes, yes. Practice also helps.
if
Yes.
you solve 5 questions or 6 questions, you will more or less know how to go about it.
Correct.
Okay. So I think there are two main chunks that are remaining. Tomorrow, let me confirm the time. Let me see if I can allocate a half an hour time just to close the loop on ALM.
Right. Okay.
Okay. Alrighty then. Any
Yeah.
questions? Any queries that you have? Please feel free.
No, as of now, nothing.
Okay. All right.
So one generic query,
Yeah,
maybe I won't take long, or maybe we can discuss at length later. So
sure.
since I'm currently